Good evening, sir.
Good evening. Good evening. Okay, let me share the screen.
So, could we discuss the potentiometer?
Yeah, we'll discuss. Meanwhile, we'll be discussing potentiometer also. What exactly is your doubt in potentiometer?
Uh, sir, like the formula or like,
Okay, okay. Yeah, that will take up questions from potentiometer.
So could you also explain those meter bridge questions?
Okay, okay. See, in potentiometer and meter bridge, basically it is based on one of the concept. If you remember, it's Wheatstone bridge concept. You know this?
yes, sir.
Yes, sir.
Okay. So we generally try to create.
Sir, you're not audible.
Sorry, there was a network problem.
Uh, Sir, in potentiometer, the doubt is in measuring the internal resistance of battery.
Measuring the internal resistance of a battery. Okay. I think I've kept one of the questions, which is your doubt basically. So maybe we can discuss that also.
Yes, sir.
Okay. Okay. I think we can start now. So let me first start with basic overview. Then we'll see the problem solving and all. Okay. So in current electricity,
So I'm not able to hear you.
Okay. Sorry, I don't know why there is continuous disconnection. Okay, so I was discussing about the current in terms of drift velocity. What was the formula for current in terms of drift velocity?
I is equal to NEA.
A V drift, correct? If you take I by A, this will be your current density, which is NE V drift. Okay, and the direction will be decided by the drift velocity. Okay. Now, this was the initial thing where we have learned that Brownian motion of electron and V average. Basically, drift velocity is the average velocity after continuous collisions. Okay, and we have seen that it is nothing but minus E by m tau. Okay, this is nothing but the acceleration in presence of any electric field, and this is relaxation time. Okay, now from this only we have defined what is resistance, that is rho L by A. Okay, where rho is nothing but, this rho was nothing but mass of electron divided by n concentration E square tau. Okay, so from all these relation we generally see this most common formulas of resistance and all. Then we have seen the conductivity. Conductivity is opposite of resistivity. Okay, then there are other important formulas also, like in terms of current density. Let's say this is your current density, then sigma into E, that is conductivity into electric field, or you can say it is 1 by rho resistivity into electric field. Okay, so these are some common expressions which you should know so that you will be able to solve it quickly. Okay, then we have seen that whenever we are talking about resistance, which is R rho L by A, this length we are talking about the length along the direction of current, and area will be perpendicular to the flow of current. Okay, and then you might have studied different arrangements in which you need to calculate total resistance. Okay, then one more thing, that is resistance is temperature dependent. That means R naught 1 plus alpha delta T. Okay, then comes Ohm's law. We are all are familiar with Ohm's law. Okay, afterwards, and we have seen Kirchhoff's law. Kirchhoff's law consists of two laws. Basically, there are two important law. First one is junction law. That means all incoming current is equal to outgoing current. Second is loop law. Correct. In loop law, if you are starting from a point in a circuit and you are moving in a closed loop, then the change in potential will be zero. Okay, and also we have seen the equation of power, which is V into I. Okay, now we have seen that in case of resistor, unlike capacitor, it dissipates energy due to heating. Okay, then we must have studied about the equivalence of battery. What is series equivalence of battery?
The summation.
Yeah. What is parallel?
E by R equivalent is equal to E1 by R1 plus E2 by R2.
Yes, E1 by R1 plus E2 by R2 and so on, divided by 1 by R1 plus 1 by R2 and so on. Okay. And yeah, there will be multiple question based on application of loop law also. And there are some good questions also. Then I think comes the concept of series resistance and series parallel resistance. We already study from class 10th itself, so it's okay, I think. Then Wheatstone bridge, because potentiometer and meter bridge is based on the concept of Wheatstone bridge. Okay, The basic structure of Wheatstone bridge look like this basically. Let's say this is R1, this is R2, this is R3, this is R4, this is R5. The Wheatstone is said to be balanced if R1, R2 is equal to R3, R4. In this condition, I is equal to 0 through R5. Okay. So this will be the basics for potentiometer and meter bridge. Okay. Now with help of Wheatstone bridge, you must be calculating some questions of finding equivalent resistance. Then solving equivalent resistance problem using symmetry. Okay. Like let's say some symmetrical figure is there. Okay. Now if current is going like this, so for after this point, these 2 points will be symmetrical, so their potential will be same. And these 2 points will be symmetrical, so their potential will be same. So you can just overlap this and find the equivalent resistance using the concept of symmetry. Okay. Then delta star transformation is also one of the tool which you can use to solve the problem of finding equivalent resistance. Let's say this is your delta transform. This is your delta circuit, and we want to transform this into star configuration like this. If you are saying this to be R1, R2, R3, this is A, B, C, then this is your A, this is your B, this is your C. Now the resistance for this will be given as R1, R2, basically the two resistance multiplication divided by total sum. Okay, this is R1, sorry, R1, R3 divided by R1 because this is R1 and R3, R1 plus R2 plus R3. This is R2, R3 divided by R1 plus R2 plus R3. Okay, so this also sometime will be helpful if you are going for some equivalent circuit problem. Okay, then next we have discussed for batteries. Then yeah, instruments. In instruments, mainly there are galvanometer, ammeter, and all. But as you said, the important part is the potentiometer and meter bridge. Okay, I think in class 12th you all have done the experiment related to meter bridge. Correct?
Yes, sir.
And you must be aware of the setup of meter bridge because there must be this kind of structure. Okay, and this is connected through a conducting wire, and there were two resistance. Okay, now at this point there is a galvanometer G, you can say, whose jockey you can put it here. So let's say this is X and total is generally 100 centimeters, so 100 minus X. Okay, so the moment you are getting the null point, that means the circuit is balanced Wheatstone bridge. So generally in the lab setup, one resistance will be known. Okay, and any other resistance must be unknown. And this X, the resistance for X and 100 minus X, we can calculate if you know the resistivity, length, and cross-sectional area. Cross-sectional area must be given to you, or you can find it using screw gauge. Okay. So rho L by A will be the area. Rho is same, so rho by A will be same. So this is, let's say, rho L. This will be what? Rho L minus 100. Sorry, 100 minus L. 100 minus L divided by A. Correct? R is known. 3 resistance we know. And since you are getting the null point, then it means that there is no current between these 2 points. So you can simply cross multiply the resistance and equate them. Thereby, you'll be getting the unknown resistance as R 100 minus L divided by L. This is the formula for finding the unknown resistance in meter bridge. Okay. Now we can come to potentiometer. Potentiometer is also similar kind of setup. Let me just go through it. Potentiometer. Okay. In this, we have by battery. Let's say this is its internal resistance, and this is the wire. Let me draw it like this. Okay. This is point A. This is point B. This is EMF of the battery, and this is internal resistance. Okay. Now, in this case, again, we'll be taking the help of balanced Wheatstone bridge itself. Okay. So let's say, or you can just take help of Kirchhoff's loop law also. Let's say due to when the circuit is closed, some current I is flowing in the circuit. Let's say some current I is flowing in the circuit like this. Now, what should be the value of I? I should be equal to E by R plus R. Okay. If you're naming this A and B, so what is potential difference across A and B? VA minus VB is nothing but whatever resistance is there into current. I into R. Because R is the resistance for this wire, and let's say its length is L. I is nothing but E by R plus R multiplied by this I. Okay. So in this case, you can say that this VA minus VB is the maximum potential difference that can be measured. That can be measured using potentiometer. Okay. And what is potential gradient in this case? That is for how much length, what will be the potential drop. So it is called as potential gradient, which is X, let's say, is equal to the total voltage drop divided by total length. So if you want to write in terms of battery value and all, it will be R plus R, R by L. So it is volt per meter. Okay. Now, what is use of potentiometer? Potentiometer is generally used, let's say, to find the voltage of unknown battery. Okay. Let me draw another circuit diagram so that it will be clear. So we have this battery internal resistance, and this is your setup for potentiometer. Now we'll be connecting parallelly a battery of unknown voltage. Okay, let's say this is V plus minus, and now this will be, there will be a galvanometer, and this there is a jockey. Okay, the moment the potential drop across them is equal, okay, the deflection will be zero. Okay, So that will be, let's say this is the x distance at which we are getting zero deflection, then the potential drop must be equal to x into L. Sorry, this will be L. X is the voltage gradient. So the potential drop will be voltage gradient into length. Okay, understood? So similarly, you can take one known, one unknown, then finally you can find the unknown voltage for a given battery. Basically, the formula, if you remember, it is L2 by L1 E1. So E1 is known, L1 is known. Similarly, if you have E2 and L2, that means another battery of unknown voltage, then you can use the same thing again and again and relate the two. Thereby, you'll be getting E2 equal to L2 by L1 E1. Okay. Similarly, there are multiple uses, and like one have asked to find internal resistance of a battery using potentiometer. Let me discuss that also. Okay. So in this setup, what we have is, first of all, our potentiometer setup like this. Okay. Now we'll be connecting a battery. Okay. It will have some internal resistance R, which is what we need to find here. Okay. Now there is another branch and there will be one switch, and there will be another resistance like this, and the 2 points are connected. Now this is known resistance and this is unknown. Okay, and the battery EMF is given to you as E. Okay, when you are connecting the first part, let's say we are connecting this part with the help of jockey and we are finding the null point, then we'll be getting one L1, correct? That length will correspond to some voltage. Basically, X into L1 will be that voltage, correct? So it will give you potential drop across this, correct? Now, again, if you connect this circuit and you connect this part with the circuit, you'll be getting another condition, that is L2. So from these relations, we'll be having two equations, and finally the formula for internal resistance is L1 minus L2 divided by L2. This is the formula for internal resistance using potentiometer. Okay. Then I think, yeah, these are the important topics from current electricity. Now we can start with the problem solving. Okay, one by one. Okay, let's solve this question.
So the question is not fully visible.
Okay, okay, let me check. Now it's clear?
Yes, sir.
Okay. Yeah. I think 15.6 ohms would be the correct answer. Okay. Let's see the solution. In this question, we know that resistance is equal to rho L by A. Okay. And if you want to write in terms of what you can say volume, because here for a fixed volume of wire, if you are increasing the length, then area has to decrease. So let's keep this in terms of volume so that there won't be varying area. We know that volume is nothing but A into L. This implies area is equal to V by L. So you can replace this with V. This is L square. So rho L square by V. This way, we got this relation for constant volume and rho, R is directly proportional to L square. Okay. Now, according to the question, you are increasing the length by 1 point or basically 25%. So new length will be 1.25 L. Similarly, new resistance will be what? Whatever initial resistance was there, and since it is dependent on the length square, so the ratio of new length by original length whole square, which is 10 into 1.25 whole square, because L dash is 1.25 L. So if you multiply it, you'll be getting 15.625 ohm. Okay. Okay. Try this one. Yeah, option C is the correct answer. Basically, this is formula based question, which is some initial R1 is given to you at given temperature. Okay. Now they are saying that if the temperature coefficient is also given to you, the temperature at which the resistance will become this. So R2 and R1 is given, simply T2 is not given to you. So you can use this formula 1 plus alpha delta T. Put the values, you'll be getting 9, somewhere around 970, 80, I think. And closest possible answer is this only. Okay. Okay. Try this one. If you remember, mobility formula is Vd by E. Okay. And E is nothing but voltage drop per unit length. So it will be Vd into L by V. Now you can solve. Yeah, D is the correct answer. If you put the values, every value is given to you already. You'll be getting 5 into 10 to the power minus 3 as your answer. Okay, try this one. This is also a question based on same concept where resistance was directly proportional to length square. D. Yeah, D is the correct answer. Since we know that R is directly proportional to L square, so initial resistance, if you are taking R, so if you are doubling the length, so next will be 4R. So what will be the percentage? Percentage it will be initial divided by final minus initial into 100. That is 300%. Okay, try this one. Yes, option B is the correct answer. Basically, in this question, function which current is given in terms of time. Okay, and we know that I is equal to dq by dt. Okay, and we want to basically find what is total charge flown first of all, then only we can find what is total number of electron that is flowing. So q is nothing but integration of I dt. Okay, and time is varying from 0 to 50 second. Okay, and integration is very simple. Simply 4 minus 0.080, you need to integrate it I dt simply. Okay, like this is your q, which is nothing but I dt. where I time varies from 0 to 50 and I is given as 4 minus 0.08 t dt. If you do this integration, you must be getting somewhere around 100 coulomb. Now, this is total charge which is flowing. We want the total number of electron. So charge of one electron is how much? 1.6 into 10 to the power minus 19. So total number of electron will be this. So it is 6.25 into 10 to the power 20 electron. So option B is the correct answer. Okay, try this one. This one is easy. I think so. A. Yeah, A is the correct answer. Okay. So in the upper branch, we have 5 ohm of resistance, correct? In the lower branch, we have 10 ohm of resistance. So they are in parallel. So the final R equivalent will be 5 into 10 divided by 5 plus 10. That is 50 by 15. 5 is 10 by 3 ohm is the correct answer. Okay. Solve this. Okay. Option C is the correct answer for this question. Let's see the solution part. Now in this question, the equivalent total equivalent resistance, if you look at, it is first of all 12 into 4 by 12 plus 4 plus 2 plus 1, because this is 1 ohm also. Now it is 12, 4 is 48 divided by 16, that is 3 plus 2 plus 1. So 6 ohm is the total resistance of the circuit. So total current must be equal to 2 ampere. Correct? Now this 2 ampere is going, now it has to be divided into two branches. The one who's having higher current, sorry, higher resistance will be having lesser current. So you can just say that I1 is nothing but 4 divided by 12 plus 4 multiplied by 2. So 8 divided by 16, that is 1 by 2, 0.5 ampere. I2 will be equal to 2 into 12 divided by 12 plus 4. That is also 1.5 ampere. So option, I think C is the correct answer. Okay. Okay. Try this one. Yeah, option D is the correct answer. Here in this question, two resistance are given. Okay. The thermal energy developed in the ratio. Simply formula based question is there. Okay. So if you use the formula, simply H1 by H2 is nothing but uh, V square. Since V will be, they are constant, so V will be constant. So that means they will get cancelled. What left will be 2R by R. That is 2H2. So option D is the correct answer. Okay, try this one. No, option A is not correct. Yeah, option C is the correct answer. So the equivalent resistance between the 2 point. So we can start from here. These two are in series, 2 to 4. 4 and 4 are in parallel, so that will become 2. Again, 2 and 2 is 4. 4 is parallel, so this will become 2. So finally, you will be having 2 to 4. Okay, 8 and 4. Basically, one will be 4 ohm, second will be 8 ohm. So 8 into 4 by 8 plus 4, that is 32 by 12, that is 8 by 3. Okay, try this one. Yeah, B is the correct answer. So in this question, these two are in parallel. So first of all, this will be 3 ohm. This is 3 by 2 ohm. This will be 6 into 2, 12 by 8. That is 3 by 4. Sorry, this is 3 by 4. Okay, we are basically dealing with this. So these two are in series, 3 by 2 and 3 by 4. So it will be how much? 3 by 2 plus 3 by 4, that is 4. 6 plus 3, it is 9 by 4. And now 9 by 4 and 3 are in parallel. So 9 by 4 into 3 divided by 9 by 4 plus 3. It will be 27 by 4 divided by 9 plus 12 by 4. So it is 27 divided by 19. Okay. I think I'm doing any mistake I'm making. Okay. Okay, let's take final answer. So this is basically the total resistance. So current will be 9 divided by 27 into 19. So this is 3. Yeah, somewhere around 19 by 3, that is 6 ampere should be the correct answer. Okay. Okay. Try this one. Yeah, B is the correct answer. So in this question, three resistors are there. They are forming a triangle like this. This is 1, 2, and 3. Now they are saying across 3 ohm resistor, a 3-volt battery is there. Okay. The current through 3 ohm resistor is. So basically this and this is 3. 3 by 3 is 3 by 2. Correct. So R equivalent is 3 by 2. So total current will be 3 divided by 3 into 2, which is 2 ampere. And this branch is having 3 ohm resistance. So current will be equally divided. So current will be sorry, 1 ampere. Okay. Try this one. Sorry, please make this make a correction. It should be A and B. Yes. No answers. Yeah, B is the correct answer. So in this question, if you look carefully, then this is symmetrical about this line. That means the potential of these 2 points and these 2 points will be same. So this is meaningless. So we are having just one branch which is AB and one branch which is CD. So it is like a series combination of three resistance, that is 5, 10, and 5. So overall resistance for AB, or you can say net resistance across AB, should be 20. So B should be the correct answer. Okay, try this one.
So if it was A and D, how would we do it?
No, we cannot find A and D, no, because see, this is like a disconnected circuit.
So then it cannot happen.
Yeah. Okay. Anyone got the answer? C. Yeah, C is the correct answer. So if you look carefully, this is symmetrical about this axis, correct? So what we can say is, if this is symmetrical about this axis, then these potentials will be equal. So if this potential is equal, that means this is like a balanced bridge layout. Okay. And the diagonal element won't carry any current. So we'll be having, first of all, one, wait, 15 plus 15. Okay. And another path is 15 plus 15. Okay. And middle path is also there, that is 15. How much of you got the answer as 10? Only Kanishka. Anurag?
So I didn't. I took some. I was still solving.
Oh, you solved, no problem. Take few minutes.
Sir, if you take the horizontal symmetry, sir, then in that case, it's not coming out to be 10. It'll come to be 8.
See, we cannot take this as a horizontal symmetry because we want to find the equivalent resistance across AB. Okay, one side is A, one side is B. That's why.
So, but there's another method, no? If you have like horizontal symmetry, then you can separate the joint. Like, then it'll just be 50 or
See,
between.
line of symmetry, horizontal symmetry is also there. But which line we should be using when we need to take care of this point also? Across these points, there should be line of symmetry. So if you are drawing this line, is it symmetrical about these 2 points?
Okay, sir.
Okay.
Yes.
Sir, I'm not getting. You can go ahead.
Okay. Okay. See, in this question, first of all, we need to look at the symmetrical points, or you can say equipotential points. That means if I'm drawing this as our symmetrical line, correct? Then this point and this point are symmetrically opposite point, correct? And at the same time, if you look carefully, this intersection does not mean anything because due to symmetry, whatever current is going here will go there, and whatever current is going here will go there. So if you want to draw a referenced diagram, then it will look like this, first of all. Okay, A, B, C, B. Now every wire is having 15 ohm resistance. So this is 1, 2, 3. So this has how much? This is 15. This is 15. This is 15. Okay. So 15 plus 15 is 30, and 30 is in parallel with 15. Correct. So what we are getting in A, B, C, B branch, what is the resistance? It is 15 plus 15, correct? Now 15 and 30 are in parallel. That means 15 into 30 divided by 15 plus 30. This implies 30 plus 450 divided by 45. This is 10. So it is, sorry, 40. Correct? Is the calculation of 15, 15, 30, 15, 3, 450, 45. This is 10, 40. Yeah. Now, so what about this branch? Let's keep it O. AOB, this is again 30. That is 15 and that is 15. So 40 is there. Then 30 is there. And in this, it is 15. So these three are in parallel. Let's check the answer.
So,
What?
wouldn't 15 and 15 be in series because it's in the same branch?
This one,
Yes, sir.
yeah, they are in series. That's why I've written 30. So for
Oh,
this whole thing, this is 40. This whole thing, this is 30. What left is this, which is 15. So they all are in parallel. So 1 by 40 plus 1 by 30 plus 1 by 15 will be your 1 by R equivalent. Okay. What is the LCM of this? I think 120 will be the LCM. So this is 3 plus 4 plus 8. Correct? So it is somewhere around 8, 4, 12, 15 by 120. So yeah, 8 is the correct answer. Who was getting 8?
sir, I told you, sir.
Okay, okay. Yeah, 8 ohm is the correct answer. Okay. try this one. Yes, D is the correct answer. So in this question, you need to, let's say this is VD, okay, potential of D. Now let's assume that all currents are going outward. So you can say that sum of all outgoing currents would be zero. We have seen this in Kirchhoff's junction law. That means VD minus 70 divided by what is the resistance 10 plus VD minus 1 is 0, that is having resistance 20, plus VD minus 10 by 30 equal to 0. If you solve this, you'll be getting VD as 40 volts. Okay. Now we know the potential difference of point D. Accordingly, the current in branch AD will be nothing but the potential difference, which is 30 by 10, that is 3 ampere. Then dB is 40 by 20, that is 2 ampere. Current in DC is 30 by 30, that is 40 minus 10, which is 1 ampere. So the correct answer should be 3 is to 2 is to 1. So option B is the correct answer. Okay. Uh, Today, I think we have lost some time due to network issue. So maybe we can start with magnetic property, magnetic moving charges and magnetism also. Okay, before that, let me just give a brief introduction. Okay, so in magnetism, as you all know, basically it's all about formulas. If you remember the formula correctly and some basic nuances related to that formula, then you'd be able to solve the questions, correct? Because we don't know what is the like origin of magnetism is related to special theory of relativity. So we generally deal with straightforward empirical formulas and using that, and there are some formulas involving cross product, okay, like qv cross b. So if you know the formula and basic concepts, you will be able to solve the problems of magnetic effect of current. Okay, and the questions from this topic will not be that difficult. The only challenge is if you remember the basics. Okay, so like what is Biot-Savart's law? What does it gives you? Or before that, let me ask, what is a magnetic field due to moving charge? Let's say a charge is moving in magnetic sorry, a charge is moving, let's say, and due to this moving charge, what will be the magnetic field? So we have seen one formula that magnetic field due to moving charge is mu naught by 4 pi q v sine theta by r square. Okay, or in other way, in vector form, you can write that b vector is equal to mu naught by 4 pi q v cross r divided by rq. Okay, because if a charge is moving, let's say, in this direction, and we want at any point r what is magnetic field due to this moving charge, then this is the formula we have to use. Okay, then comes Biot-Savart's law, which is very familiar, I think, for you also. Biot-Savart's law, which tells that if, let's say, current carrying conductor is there, then if you take a small current element, which we generally call it dl, okay, and its direction will be in the direction of current. Here dl is a vector. Now due to this current carrying wire, we want electric field at any point P. Okay, and since the direction of current is this, so electric field will be in the into the page, and angle between them is theta. Basically, this is your dl vector, and this is your r vector. So the angle between them is your theta. So from this, we have seen that a small magnetic field due to that small element is nothing but mu naught by 4 pi I dl cross r by r cube. This is basically differential form of Biot-Savart's law, which we generally use to find for any other geometrical configuration. Okay, let's say that we are having a current carrying wire like this, finite wire is there, and current going is I. Now at any point P, let's say we draw a perpendicular, and these are the two angles, that is theta 1 and theta 2, then we have seen that B due to this condition at point P is just like what we have discussed in case of electric field, mu naught I by 4 pi r sine theta 1 plus sine theta 2. This is also important formula. If you put theta 1 and theta 2 infinity, you'll be getting sorry, theta 1 and theta 2 90 degree for infinitely large wire, you'll be getting mu naught I by 2 by r. Okay, all this formula comes from Biot-Savart's law. And there is many more application in problem you will see for semi-infinite wire, for high, like both side both end is going towards infinity. Okay, and for arc, what is magnetic field due to current carrying circular loop? This is also very commonly asked or commonly applied question, that is what is magnetic field due to current carrying loop at the center? It is mu naught ni divided by 2r. Okay, n is nothing but number of turns. Okay, now you can use this Biot-Savart's law to find electric magnetic field due to any geometry, okay, like arc and all those things. And there is one common problem. I think it's better you remember the answer for this, because it is typically asked in most of the question exam, that if, let's say, current is going like this, so further current will be bifurcated like this. Correct? Now, what is the net magnetic field at center? It should be zero, because the current will be more on the lesser resistance side, and the current will be less on the higher resistance side. Accordingly, the angle will also compensate for each other, and finally, if you solve, you'll get zero as the answer. So instead of wasting so much time, you can just remember this standard relation. Okay, and In magnetism chapter, yeah, most of the thing is mostly about the formulas and questions. So now let's try some problems based on what we have discussed. And what is magnetic field due to solenoid at the core? Mu naught Ni. Okay. Okay. Try this question.
Sir, I'm not getting any of the options.
Uh, what is the answer you are getting?
I'm going into 10 raised to minus 1.
-1. Okay, okay, okay. Let me check the answer. So we have a solenoid and length is given, radius is given, turns is given, current is also given, and we know that magnetic field is nothing but mu naught N I. Correct? N is number of turns per unit length. Correct? N by L. So number of turns is 400. Length is how much? 0.4. It is centimeter, no? So let's keep it in meter then. 0.4 into 10 to the power 2. Yeah. Okay. So it will be 4, 1, 2, 3, 4. These two and these two, and one more zero will be there if you take the decimal out. So it will be 1, 2, 3, 4, 5. So basically it is 10 to the power 5. Correct? So 10 to the power 5. I think there is something wrong. I think it should be in meter. Then only you'll be getting realistic values. Okay, because it seems a bit not realistic, like 10 to the power 5 turns per meter. So let me take it in terms of 0.4 meter. Then it will be how much? It will be n equal to 400 divided by 0.4. So it will be 1000. Correct? Now mu naught is 4 pi into 10 to the power minus 7. Turn is 1000. Current is 5 ampere. So we must be getting 4 into 3.14 multiplied by 5 into 10 to the power minus 4. 5, 4, 20, 23, 60. So something around 6 point something into 10 to the power minus 3. So I think option B should be the correct answer. Okay. That's why you are getting wrong answer.
Yes, sir.
Okay. Please correct this. Then I think your answer is correct only.
Right.
B. Yeah, B is the correct answer. Basically, this part and this part won't contribute anything in magnetic field. Only this circular part will contribute magnetic field, but the direction of current is opposite. So their contribution will get subtracted. And we know the formula for semicircle is mu naught I by 4R. Correct? So the result will be, final result will be what? Mu naught I by 4, 1 by R1 minus 1 by R2, because their direction is opposite. So B should be the correct answer. Okay, try this one. This one is formula based. If you know the formula, I've just told you the formula actually. It should be option A. Okay, okay, try this one. This is also actually formula based problem. These formula you need to remember. Yeah, D is the correct answer. D is the correct answer. That if a infinite straight carrying conductor is there, then magnetic field situated at any distance r will be mu naught I by 2 pi r. This is important. You should remember this. Okay, try this one. Yeah, B is the correct answer. So we know the formula for this. Okay, that magnetic field due to a current carrying conductor at a point is mu naught I by 2 pi r. Correct. Now the thing is, their direction will be opposite, so net field will be the subtractive field. So magnetic field due to 2 ampere and 1 ampere will be what? Mu naught 2 mu naught by 2 pi r minus mu naught by pi r. So basically what you are getting is B only, which is already given. So new field, if let's say you are switching off the 2 ampere, the only contribution will be 1. So still you'll be getting B only. Yeah. So B is the correct answer. That is it. Basically we are using this formula if you know mu naught I by 2 pi r, but you need to keep the direction also in your mind. Okay, because net effect will be the subtraction of 2 ampere and 1 ampere. So finally effectively you are getting 1 ampere only, and if you are switching off 2 ampere, then also effectively you are getting 1 ampere. So magnetic field won't change, and the answer should be B. Okay, see this. See, this is basically a formula based question. If you know the formula, then only you will be able to solve, because deriving the formula in exam, it will be difficult. Okay, so if let's say a circular coil is there, okay, now at the center magnetic field, let's say it's anything B at the B. Now, any point on the axis, magnetic field will be decided by B at the center, R square, that is R of loop, and X is the distance at which we are trying to find, R square plus X square divided by 3 by 2. Okay. Now, it is B, it is R square, and the distance is itself R. So, R square plus R square is 2R square. So, it is 1 by 2, 2 to the power 3 by 2. So, it will be root of, yeah, B divided by root 8. Option C should be the correct answer. Okay, try this one. Here the current is like this. Yeah. Yeah, option D is the correct answer because equal and opposite current will be going and they are in a direction such a way that they will create magnetic field but in opposite direction. So they will cancel and only this happens only in P and R, not in Q. So P and R is the correct answer. Okay. See this question. Yeah, I've just given you this concept basically in the introduction that anywhere you see a question like this, that when a circular ring is there, circular path is there, closed path is there, okay, then the net field will be zero. Okay, try this one. Yeah, D is the correct answer. See, in this question also the formula is same. So in first case, magnetic field is given. In second case, magnetic field is given. But in first case, field will be subtractive. In second case, field will be additive. Okay, so let's say mu naught I by 2 pi r is the question formula. So, but mu naught by 2 pi r is a constant. So we can just see that some constant c multiplied by I1 minus I2, because initially the field are in the current are in parallel direction. Okay, which is given to you as 6 into 10 to the power minus 6. In second case, same constant will be there, that is I1 plus I2, and the magnetic field in this case was given as 30 into 10 to the power minus 6. Okay, now in question we need the ratio of I1 by I2. What we can do is we can divide the two, that is I1 minus I2 divided by I1 plus I2 is equal to, I think, 1 by 5. Okay, so we need to cross multiply it. 5 I1 minus 5 I2 is equal to I1 plus I2. This implies this is how much? 5 minus 1, 4 I1. Sorry. Yes. Just wait a minute, okay? My pencil got discharged. Okay, so this is 4 I1 and this is 6 I2, correct? So I1 by I2 will be equal to 6 by 4, that is 3 by 2. So yeah, D is the correct answer. Okay, try this one. Yes, option C is the correct answer. Basically, the magnetic field at the axis of conductor is zero, because whenever we are taking any position vector r, okay, it will become zero if the point is lying on the axis. So its clear cut answer is option C. Okay, try this one. Same question I think we have just discussed. Use that formula. Yeah, yeah, option C is the correct answer. Basically, it was based on that same problem. I think it was, yeah, based on this formula, this question is there. Okay, and the answer should be option C. Okay, because BE by BA is nothing but 1 by R square divided by r square plus, because distance is x is also r, 3 by 2. Basically, it is 2 to the power 3 by 2. That is 2 root 2. Okay. Okay. See this question. K-CET PYQ. Yeah, option A is the correct answer. So in this question, the magnetic field at center is first of all is due to this 3/4 of the circle. Okay. And it will be nothing but, you can say that 3 by 4th of a circle. If you see, you'll be getting 3 by 4 of mu naught I by 2r. Okay. But what about these semi-infinite lines? Magnetic field due to this will be zero, correct? Because it is passing through the center. And magnetic field due to this one is mu naught I by 4 pi r. So if you add this and this, you'll be getting A as the correct answer. Okay. See this question. Yeah, B is the correct answer. So in this question, we know that magnetic field is directly proportional to number of turns but inversely proportional to the radius. Correct? Now, if you increase the turns, basically if n is becoming 3n, then r has to decrease by r by 3 because they are related by this relation. Okay. Now, in this question, we are increasing the turn but decreasing the radius. So both effect will increase the magnetic field. That is B into 3 into 3. That is 9B is the answer. Okay. See this one. This one is easy, I think. Yeah, most of you have given the correct answer. Option A. The particle moving is moving and magnetic field is perpendicular to the velocity. Okay, see this one. Kinetic energy is nothing but half mv square. You need to just relate the circular motion formulas and you'll get the answer. Okay. So it is half m. We know it's omega r. So omega square r square. Okay. And what is omega? Omega is 2 pi into frequency. So half m 2 pi. Basically it's 2 pi mu whole square r square. If you look carefully, you will be getting 2 pi square m mu square r square. So option C should be the correct answer. This is also a formula only. If you know, it's fine. Otherwise, you can find it using this method. The option C is the correct answer. Wait, yeah, solve this one. Yeah, A is the correct answer. We all know that moment of inertia is nothing but I into A. And there is no N. Basically, it's NIA, but there is no N in this case. And I is what? I is dq by dt. Okay. So Q is the charge. Time it will take to complete one circle is 2 pi r by V. Okay. Multiplied by the area. So finally you'll be getting QVR by 2. That is option A is your answer. Okay. See this question. This is also a standard formula basically. If you know, it will be like easy go. Most of you have said A. A is the correct answer. You should remember this actually. Okay. Try this one. B. Yes, B is the correct answer. We all know the formula of dipole energy is nothing but MB cos theta 1 minus cos theta 2. So MB cos theta 1 is 0. So basically it is 1. Minus 1 it is minus 1. So it will be 2 MB. Okay. So 2 MB is the correct answer. Okay. Try this one. I think B should be the correct option. Yeah, B is the correct answer. So we have a circle of radius r, and with the same length we are making a square. That means 2 pi r is equal to 4a. That is a is equal to pi r by 2. Correct? Now we know magnetic moment is I into A. Current, they are saying that it should be same. So final ratio is nothing but ratio of area of circle by area of square for a given length. And we know area of circle is pi r square. And we know the side of square is pi r by 2. So it will be pi r by 2 whole square. Finally, you'll be getting 4 by pi as your answer. Okay. So these are the questions from magnetism and current electricity. Please revise the topics for the coming session. Okay. And we'll meet in the next session. Okay. Thank you, everyone.
Thank you, sir. Bye.